Again, we're being asked to find the factors, but I notice here this is a trinomial and it skips the third and the first degree terms. This is actually going to factor. We're going to have x squared minus 13 in one parenthesis and x squared plus 1 in the other. Now this actually factors further. We're not used to factoring it this way, but it's still going to factor. This is the difference of two squares, even though 13 is not our favorite square. But if the shoe don't fit, force it. So we're going to have x minus root 13. See what I mean by force it? X minus root 13 and x plus root 13. When you have the sum of two squares, it does not factor over the reals. You treat it like the difference of two squares. So x plus 1, x minus 1. But then you stick an I at the end of each parenthesis. We have x plus 1i, x minus 1i. And that is your factored form. You can check it by multiplying together. So it turns out that our zeros of this function are plus and minus root 13 and plus or minus I. We have two irrational but real solutions and two imaginary solutions. And this theorem follows directly from what we just found here. Basically it says when you have real coefficients for your polynomial, and you find that you have one complex number as a solution, basically it says they will travel in pairs, and if a plus bi is a solution, then a minus bi will be a solution. So here we go. They're telling us 3 minus I is a 0. We know that 3 plus I will also be a 0, but they're asking us to do this the long way here. So here we go. 3 minus I is a 0. We're going to have 1, negative 6, 5, 30, and negative 50 as our coefficients. We're going to bring down our leading coefficient of 1 there, and we're going to begin this multiplication process. So 3 minus I times 1 is 3 minus I, and combining like terms, the 3 and the negative 6 combine together to give us negative 3 minus I. Now we need to multiply together this 3 minus I times negative 3 minus I. First term of the FOIL is negative 9. We then have minus 3i plus 3i and minus I squared. So these middle terms are going to cancel. We're going to have negative 9 plus 1 making minus negative 1 plus 1 making negative 8. And so basically now we're going to have a negative 8 in here. I've made a mistake in there. Plus I squared. Plus I squared. Therefore we have negative 10. And so we're going to have a negative 10 in here. And adding down we have negative 5. We distribute here and we get negative 15 plus 5i, and adding down we have 15 plus 5i. We now need to multiply that by the 3 minus I out in front. So here we go, 3 minus I times 15 plus 5i will give us 45 out front. We will then have a plus 59, a minus 59, which will cancel out, and a minus 5i squared, which will be 45 plus 5, which is 50. That puts a 50 in here, and we have a remainder of 0. Phew, that's a lot of work. But now what we need to do is break this down further. We want to see that 3 plus I is also going to be 0. So our coefficients here are 1, negative 3 minus I, negative 5, and 15 plus 5i for our next synthetic division. Bring down our leading 1. 3 plus I times 1 is 3 plus I. Looky there, those cancel each other out, we get 0. Bring a 0 then right there. Add down negative 5. Distribute, get negative 15 minus 5i, and we got a 0. Ba-bam. So now what do we have? We now have that our function f of x is equal to x minus the 3 minus I that we factored out the first time, times x minus the 3 plus I that we just factored out this time times x squared minus 5. Now we're being asked to find all the zeros, and I think we pretty much have our answer here. The zeros are 3 plus and minus I, are two conjugates that travel together, and when we do the difference of two squares right here, we will find out that plus and minus the square root of 5 are the other factors. Continuing on though, we're being asked to write this as a product of linear factors, which means we're going to have f of x equals, bracket x minus the 3 minus I times next bracket x minus the 3 plus I times next, and I'll change it to a parentheses, x minus root 5 times x plus root 5. Now, the reason these are linear factors is because each of these factors has x to the first inside. Now, solving this equation basically tells us we will have 3 plus and minus I as well as plus and minus the square root of 5. All we're dealing with here, the difference between parts A, B, and C, is the vocabulary and how they are writing these directions out.